In this video, we're going to look at Dalton's Law of partial pressures. So we're talking about partial pressure. We're talking about the pressure exerted by a single gas when it's in a system of gases. So Dalton's Law of partial pressures depends on the total number of gases, not necessarily the type of gas that is present. And when you've got a mixture of gases, the total pressure is going to be equal to the individual pressures of the gases added up. So the P total is the total pressure, A, B, and C are letters just representing gases in a system. So if we want to do this mathematically though, we've got a few constants that cancel out, and in the end we're left with this expression here, where the A is representing whatever gas we're talking about. So PA is the pressure of gas A, and P total, pressure total, is usually given in the question. And this last part here is our mole fraction. So what we're going to need to do is find the moles of gas A and also find the total moles in our system. So we've got a typical question here. We've got 10 grams of argon, 16 grams of oxygen, and 22 grams of carbon dioxide. And we're actually given our total pressure rate here is 100 kilopascals. We're going to want to find the partial pressures. So our first step is we're going to find the moles of each gas. So let's find the moles of argon. So if we have 10 grams of argon, argon's molar mass is 39, so basically 40. You can cancel out the units, and you're left with about 0.25 moles of argon. Moles of oxygen is going to be 16 grams, and its molar mass is going to be 32. So again, we can cancel out the grams, and that gives us about 0.5 moles of oxygen. And lastly, for carbon dioxide, we have 22 grams, and we again end up with 0.5 moles of carbon dioxide here. So our next step is we're going to add up all the moles. So our total moles is going to be equal to that 0.25 moles of argon plus the 0.5 moles of oxygen and the 0.5 moles of carbon dioxide, giving us a total of 1.25 moles. Okay, our next step is we're going to use that equation from earlier in the video to figure out the pressure of each gas. There it is. So gas A in this case is going to be argon. Now I do want to point out that our pressure total was given in the question as 100 kilopascals. So that's supposed to be 100 kilopascals there. So we've got argon. Now recall that we found there were 0.25 moles of argon, and remember this bottom number is our total moles discovered. So when you go 0.25 divided by 1.25, it equals about 0.2, and then 0.2 times 100 gives you 20 kilopascals. I do want to point out here, if your gas term is not in kilopascals, say it's in atmospheres, that just means your final answers will be in atmospheres here. So it doesn't matter. You can work in any pressure term that is given. So our second gas was oxygen gas. So the only value that's going to change is our moles of oxygen. This time it's 0.5. If you divide 0.5 by 1.25, you get 0.4. 0.4 times 100 gives us 40 kilopascals. We can do a bit of a shortcut to find the pressure of our last gas using this equation here. We know that our total pressure is given as 100. We know that we found our partial pressure was 20 of the first gas, 40 of the next one. So some rearranging and basic math should give us the partial pressure of carbon dioxide to be 40 kilopascals. Notice that our three pressures, 20, 40, and 40, all add up to our total of 100 kilopascals. If you enjoyed this video, feel free to subscribe to my channel. Thank you very much.